This is 2019 AP Calculus AB pre-response question number 1. This is a calculator question. It reads, fish enter a lake at a rate modeled by the function given by this equation. Fish leave the lake at a rate given by another function. Both functions are measured in fish per hour. That's important because on the AP exam, we have to give the units when we know them. And time is measured in hours since midnight. So the starting time is 0 at midnight. All right. So rates, entering and exiting. First question, how many fish enter the lake over the 5-hour period from midnight to 5 a.m.? So from T0 to T equals 5. And we are interested in the fish entering the lake.
So here we're going to want to take the integral from 0 to 5 because those are the endpoints that we're given of the entering function only, because we're only looking for the amount of fish that enter the lake. So we take that of E of t dt and then round this answer to the nearest whole number.
Mm-hmm. And we will count it on the calculator because this is the function. Actually, we could have done it by hand also, but here we enter it on the calculator. And the answer that we get is 153,457 something. And how do we round it?
We round this to 153 fish.
Mm-hmm. And we write that this is fish. So that was the rate they entered, and the integrating by time gave us total amount of fish. That's all for part A. Next, part B. What is the average number of fish now that leave the lake per hour over the same 5-hour time period?
So here we want to use the average value formula, which is going to be 1 over b minus a times the integral from a to b of the function f of x dx. So right now we're looking at period between t equals 0 and t equals 5. So 0 is going to be a and 5 is going to be b. And we're trying to find the average number of fish that leave the lake per hour. So it's going to be 1 over 5 minus 0 times the integral from 0 to 5 of the function L of t dt. And this should essentially give the average number of fish that leave the lake per hour, because to the right of the 1 over 5 minus 0, we have the total number of fish that leave the lake over 5 hours. So when we multiply by 1/5 or divide by 5, it's essentially taking the average number of fish for each hour.
Mm-hmm. So this total leave is similar to what we did in A, total enter, but here we divided by the time interval. Mm-hmm. Okay, and again, we can count it on the calculator, and we will get 6.05903, and we need to round it. What do we round it? What do we round it on the AP exams for the answer?
This rounds to 6.06 fish per hour.
We need to round to the 3 decimal points, right?
The question...
Did they say to the 2 decimal points? Number of fish that leave the lake per hour. No, we will round to the 3 decimal points here. So just because it's a standard on the AP questions. So 605.059. And we need to write the units. What will be our units here?
Fish per hour.
Mm-hmm. Average number of fish that live per hour. So fish per hour. Okay, that's part B. Next is part C. At what time on the interval between 0 and 8 is the greatest number of fish in the lake?
So here we want to find the critical point, because if we find our critical points, then we know where the maxima and minima are located. And with those locations, we can then find the greatest, which is the absolute maximum. So in order to find the critical point.
What critical points? We want to find critical points of what?
Oh, we want to find the critical points of the number of fish. So this number of fish is given by the number that enter minus the number that leave, or we're looking at the rate of fish that enter the lake minus the rate of fish that leave the lake. So E of t minus L of t, and this needs to be equal to 0 because this is going to give us the critical point of this function, which is the rate of change of the number of fish in the lake.
That's good. I like how you said rate of change of the number of fish in the lake at every moment is rate of those that enter minus the rate of those that exit. And what happens when the rate of change of the number of fish is positive?
When the rate of change is positive, then that means the number of fish is increasing.
Total number is increasing because more enter than exit. And if it's negative, the total number is decreasing because more exit than enter, more leave than enter. All right. So the rate of change is basically the difference between this function and that function. And as you said, we want to set it to 0 because those are the points when the rate will change from positive to negative, rate of change will change from positive to negative or vice versa. So, and we would do it as the equation on the calculator. And the equation would be 20 minus 4, 16 plus 15 sine pi t over 6 minus 2 to the power 0.1 t squared. We set it equal to 0. And we use the function on the calculator for solving equations. And we get the value of t equals to 6.20356 just by entering it on the calculator. At that hour, our rate of change is 0. So what's next?
So now we want to find where it's increasing and where it's decreasing, or where the rate of change is positive and negative in relation to the point that we identified as a critical point. So we hope that this point is a maximum, which means that to the left of the point, it will be positive, and to the right, it will be negative. So in order to do that, because these functions are continuous and there's only one critical point, on either side, it has to be all positive or all negative, because otherwise it would need to pass through 0. And if it passed through 0, then we would have identified a second 0. So right now we can look at from 0, between 0 and this point t equals 6.20356. And we can test a random point in this area. So if we test t equals 1, insert that into E of t minus L of t, then we can evaluate that.
We insert it there. We get a positive answer. So we know that the rate of change is positive on this whole interval, as you explained. Otherwise, we would have had another 0. The function is continuous and cannot jump from being, this function is continuous, cannot jump from being positive to being negative without crossing a 0. So here it's positive. Total is increasing. Do we need to test the second interval, this one?
We do not need to test the second interval, because if we have a positive on the left side and we identified a critical point, then that means that this necessarily does need to change between signs. So if we stay positive...
Why cannot this be just positive and positive? Here's the function increasing, then increase slowed, and then it's increasing again.
But then on the left side, that wouldn't be positive?
Yes, it can be rate of change can be positive, then it can slow into the zero. So it's the same number is entering as leaving. And then it can be positive again, that more will be entering than leaving. So the fact that we identify the zero does not guarantee that it will be the sign of the rate of change will be different on two sides. So we do need to test the second side also because we don't know. So we take another point, maybe 7. And again, we input it into our equation, the amount of fish entering minus the amount leaving per unit of time. And we will get a negative value. So now what will happen to the total number of fish?
Now it will be decreasing.
Total will be decreasing. Mm-hmm.
And now that we see that it's increasing on the left side and decreasing on the right side, then it's clearly an upside down parabola shape, which means that the critical point we've identified is a maximum, which means that that's the maximum value on the range from 0 to t. T is between 0 and 8.
Mm-hmm. And they asked about the time. So that's the time, and that's our justification. That was the critical point, and we tested on the left side and on the right side of it. So on the left side, the rate of change was increasing as much as it could. Then it slowed, and then it started decreasing. So t equals 6. We round to 3 decimal places as usual. 6.204 hours. So that many hours after midnight. That's when we have the greatest number of fish in the lake. All right, last question. Is the rate of change in the number of fish in the lake increasing or decreasing at 5 a.m.?
Well, in order to find if this is increasing or decreasing, we can find if the derivative is positive or negative. And we need to find the derivative of the rate of change in the number of fish in the lake, which is the derivative of E of t minus L of t, or E prime of t minus L prime of t. And because we're looking at the point t equals 5, or at 5 hours after midnight, 5 a.m., we just need to find out E prime of 5 minus L prime of 5, and if that's positive or negative.
Mm-hmm. Derivative is the change of the rate of change. So yeah, E prime of t minus L prime of t. And we want to figure it out at the time 5. So we will find E prime of 5 minus L prime of 5. We can do it on the calculator. Just we can differentiate on the calculator since it's a calculator question. Or we could have also taken the derivative by hand, but that's not necessary. We enter the derivatives on the calculator and we get the value of negative 10.7228, which is negative. So what conclusion do we write?
That indicates that it's decreasing.
Mm-hmm. The rate of change is negative, so it is decreasing. It's getting small. The change of the rate of change is negative, so our rate of change is decreasing. All right, that's all for this question.